Welcome back to our DATRON Tech Day 2021 in these extraordinary times. This is our last live event for today, and we will deal with dispensing technologies. Dispensing is a technology which is encountered literally in many nooks and crannies of our daily life. So it's not only in sports apparel or in fuel cell technology, it's basically everywhere. And to show you our expertise of many decades, we have Dirk today as an expert in our live contribution, who will talk about firm and tight with safety DATRON pump technology for optimal bonding and sealing applications. This is a special contribution to this vast field of expertise, and we would like to enjoy this issue with Dirk.
So thanks, Charlotte, for the small introduction. I guess most of you knows DATRON in the past more from the subtractive manufacturing side from our HAC milling systems. Today we will have the focus on the dispensing field, our volumetrical dispensing machines. The reason is that more and more parts getting smaller and smaller, and the quality and functionality on the parts are increasing, and that's the reason why we have to look for new manufacturing systems, and dispensing technology is one of them, and that's the focus for us in the next 20 minutes. But before we will get deeper into the technology, I would like to introduce myself. My name is Dirk. I'm responsible for sales and project management in the dispensing field here at DATRON. Yeah, and I'm happy to show you in the next 20 minutes the most important points of our dispensing technology. We would like to combine it with some videos and small interviews so that you will get a good idea how our technology will work. I will start with some typical applications. So our focus at DATRON is on one component materials from low till high viscosity, including also abrasive materials. Some typical markets for us is the electronic market, automotive industry, also the air industry, and displays. Also, for example, and sensor technique. What you can see here is that one main focus is also right now the e-mobility. So we have some electronic parts here which we have to dispense some liquid gaskets on it. The same on the fuel cell side. There we have some applications for bipolar plates where we have to put some gaskets on them. Also a very big field is EMI shielding in the telecommunications industry. So we have to put some EMI material onto base stations. Also a very big field is the parts from displays and bonding from glasses into, for example, small sensors. So what all of these applications have in common are the requirements to our dispensing technology. The first and biggest important point is the functionality. So at the end, independent if you have a bonding or sealing applications, the material must be with the right volume in the right place. And so we need a very stable and precise dispensing process for that. The second step is the process reliability. That means at the end we need a high constancy from the material all over the year. That means in the winter time, in the same as in the summertime, and from Monday to Friday. So for us it's it's important that we will dispense the same material independent of the viscosity of the material and of the temperature. Sometimes in the summertime you have higher temperatures in the production facility, but at the end we need the same volume on the part. And the third point is the production time. So it's important to achieve a very short cycle time that it's possible for the machine to increase the speed. If you have a bigger part, then we can increase the speed, and we have a lower speed in the start and stopping area, for example. Also, short setup times are helpful and necessary because if you would like to change the material, you have to clean up the pump, or if you have to bring a new part onto the machine, that you have the possibility to do this in a very short time. Now I would like to go deeper into our technology, and for that I asked my colleague from the Application Center, Christoph Wehner, about the most critical areas in the dispensing bead, and we will see what he answers us.
So the most critical point at a dispensing contour is the start-stopping point and a T-joint. For the start-stopping point, we have a command. With this command, we can control the amount. So we start near at the part surface, and by driving to the wanted dispensing height, we increase the amount. And by closing the contour, we reduce the amount over the same length at the same position. And due to this fact, we have a very smooth contour at the end. By the T-joints, we have also a command. We can control the start and end docking length. So how far should be driven over the existing contour, and should be driven a little bit lower. So we have contact through this both contours. And over that, we can control this part of the contour.
Yeah, as we heard from Christoph, the most critical points are the start and stopping points and T-joints. So what we have to take care for is that we doesn't get such a result. That means that we doesn't have too many material at the end of the bead, and that we have no rest material on the tip of the needle, because then you have an unclean starting point on the next part, and also that you doesn't have any funnel under the bead. So to achieve nice start and stopping point, we can use our ramp function. You can see it over here. So we start with a lower dispensing height, then move up to the original dispensing height with a ramp. Then we have this is an electronical housing. You have the normal bead, and then we will come back to the stopping point and move the ramp the other way around, so that you have a very clean, nice and smooth start and stopping point. This function will be used if you have a closed outline, if you have open lines or T-joints, for example, then the start and stopping points are in a different way. That means here we need more material, or directly 100% of the material at the starting point, and the other way around, if the machine stops, then we doesn't need any material anymore. That means here we can't use the ramp function. Here we have to use this kind of functionality, that the material will start and stops directly. Which kind of technology allows us to produce such nice start and stopping points? So one important point to achieve such a result is that we use volumetrical pump systems. This could be piston pumps or also eccentric pumps. We at DATRON use normally gear wheel pumps. We have different sizes so that we can dispense different kind of voluminas. And also we have different pumps for with materials with a lower viscosity and with higher viscosity, and also for filled medias, for example. This pump is at the end of the dispensing process. That means we have in the background of the pump there's a servo motor, and if the servo motor stops, then the material has to stop at the tip of the needle, so that we have a very dynamical process over here. The key technology that works in the background is the integration of the pump into the software and the path control. And because of that, we are independent from the volume is independent from the speed. So you can program it completely independent. And with that, you have a lot of advantages. That means, on the one hand, it's possible to create a bead with the same volume all over the complete part. But it's also possible, if you would like to have it, to have more or less material on different specific points on the parts. Both is possible. And point are our special kind of docking strategies, as you see it before. And this kind of dispensing head that I talk about, we can combine it with different kind of machining systems. You can see it over here, some of them. So at the end, it depends of the volume that you would like to produce and the size of the parts. So we have standalone machines on the one side and also semi-automated systems with a rotating table, for example, or fully integratable machining systems. So this is the one point, and the other point is we have different sizes of machines. So it starts from at 500 to 500 millimeter and goes up to 1,500 to 1,000 millimeter. So we can combine for example, standalone machine with smaller dimensions, and also the other way around with fully inline systems. The last point is our accessories. So accessories is a very important part to achieve the quality at the end of the part. And I asked my colleague, Mr. Lukas Negede, he's the team leader from our application center in the dispensing field, what are the 3 most important accessories here at DATRON? And we will see what he answered.
Hello, I will try to explain you now about our accessories, what we are using mostly on our machine. I will start with our needle compensation unit. So this is located on the back side of the machine. So with the needle compensation unit, we are measuring the length of the needle and the position in X and Y. And we are correcting automatically the position of the needle with the software. And this is very important due to the quality of our gasket location in height and in the XY direction. So after measuring the needle, we are correcting automatically the 0 point and all kind of the position what we have on the machine. The next part is what I will try to explain you is the Xyz Probe. With this probe, we are measuring the corner or the center of round or rectangular parts. And then we set the 0 point directly on the part. And we can use also to measure the surface and correct the height difference on our work or on your workpiece. This kind of application can be done also by the laser sensor. With the laser sensor, we can detect the surface and measure all the surface level and correct automatically the height difference of the workpiece. We are using the laser sensor to detect whether the part is fixed or not fixed on your fixture, and give you like a quality control. So additional accessory what we are mostly use is the plasma cleaning unit. The plasma head will be mounted beside the dispensing head on a pneumatic slide. This is like a pre-treatment of the workpiece. So we are driving the plasma head on the surface of the part and clean the surface to have a good adhesion on the surface between the material and the workpiece. So there's another one with the chemical with primer, but this is not good to adapt it in our machine. So we are using the plasma unit to have more automatically processed. Thank you.
As we heard from Lukas, one important point is the measurement of the needle. So the middle point and the length of the needle, that's the one point, and the other point is the set height of the part. So we have the possibility to use an optical or tactile probe to measure the part if it is necessary. We have a lot of other accessories we can offer to you, so it's up to your needs. It could be a drum conveyor system, for example, if you would like to bring the material to the machine not from out of a cartridge. So if you would like to use a hobok or a bigger drum, that's possible. You also can use more than one head on the machine, so it's possible to use up to 4 heads on one machine. It's up to the application at the end. Also can use different kind of heads on one machine for different kind of materials, so that one material is in the working area and the other one is a little bit moved up in the set height. We have fine scales, we have barcode scanners, different kind of CAD/CAM systems, so we can offer you different kind of accessories up to your needs, so that it's possible to combine it to your application at the end. So at the end, or we come to an end, I would like to show you a small video from a fuel cell application. Here you can see how the machine works in real time. These are 2 different kinds of outline, but you can see we also use the ramp function, and then we move up to the maximum speed of the machine. And the other outline that we will see right now, we start with only with some lines, and at the end we combine them with one beat completely around and close the outline. So here you can see what is possible with our technology. And so I come to an end and would like to summarize it a little bit. So our focus is on one component material from a very low viscosity up to a high viscosity material, and also including abrasive medias. That's on the one hand our focus. The other point is could be also very complex outlines and parts with very small tolerances. That's our main focus. From the bead side, it's more on the smaller side. This means from 0.5 millimeters up to 5 millimeters. That's our main focus. Yeah, I hope that I give you so as much information as possible in the short time. If you have some further questions, you can reach me in the next 15 minutes over our chat function. So please send me your questions, and I try to answer you. The other way, or the other possibility, is that you will use our mail function. That means you can send me an email to experience@datron.de if you have, for example, an inquiry, if you'd like to have some samples. So please come back to me, and that's from my side. That's all. I wish you a nice day. Thanks.
Many thanks, Dirk Iller, for your contribution from our dispensing lab here at the DATRON HQ in Mühltal-Treysa. Many thanks also to the other colleagues involved in the demonstrations who made this live session possible. Now you can put your expert questions in our expert chat box. Dirk will be available for the next 15 minutes to answer any question you have regarding our DATRON dispensing technology. I would like to thank you all for joining us today for Tech Day, and I'd like to encourage you to use our virtual showroom for the remainder of the week. We still will be open, and we will be available to you via a regular chat from 9 to 5 every workday. I hope you enjoyed being with us. We certainly enjoyed being there for you. And now, as I close this live session from our announcing situation, I would like my colleagues to just switch cameras and show the rest of the team who made this entire Tech Day possible today. You cannot see everybody because many have gone back to their work situations, but All colleagues who have been active for the past couple of hours are still here in our technology center. So you can see this is all really live. So from my side, a big thank you to all colleagues, also those who are maybe watching us for this minute. We wish you all the best, good health, and we hope to see you in person very soon again. We will certainly be available to you via email, via any live situation on demand, via our virtual showroom. And of course, if you'd like to call, we certainly like to talk to you in person too. Goodbye.